Perspective drawings show the way your designs will look in real life. They are useful for communicating with a client who may not understand technical drawings. Most commonly used is the two-point perspective, and in this film we are going to construct a set of perspective grids that enable you to draw shapes receding and advancing from vanishing points. Grids can be constructed simply and be drawn over again and again by using trace. You can make accurate presentation drawings or quick sketches. The basics you will need to construct a two-point perspective grid are a canvas, which is an empty rectangle, a horizon and two vanishing points. The canvas is a frame that contains your drawing. The horizon tells you how high or low your viewing position is, and the vanishing points tell you how far away you are from the horizon. These are simple and approximate devices that create a notional pictorial space. When you draw shapes that appear above the horizon, you will create the impression that the shapes are above your head. When they occur below the horizon, you will feel like you are above the shape, looking down on it. A good way to first understand this in drawing is to experiment with changing the positions of horizons and distances between the vanishing points. Vanishing points are generally more naturalistic the further they are apart. So, once you can draw a box frame, you can subdivide it using diagonals. This is a good exercise to build your sense of proportion in perspective. You've been given a box and its sides can be subdivided by crossing diagonals from the four corners. The point where the diagonals intersect marks the middle. Draw a vertical line through the intersecting point to divide the shape equally into two. Repeat this process to divide the shape into 4, then 8, 16, and so on. You have just divided up a box frame, and you can use this method conversely to duplicate spaces, using the box provided in exercise sheet 4.4. First, double the height of your box by doubling the length of the vertical measuring line. Then draw the new box you have created in perspective as you did in your first perspective exercise. To double the width of your box, project from top left to bottom right of your original box until it intersects with the bottom line of your box at point A1. And to triple the width, repeat the process, this time from the second box, drawing a diagonal line until it intersects with the bottom line of your box at point B1. This is our grid, now on a light box. Light boxes are a way of boosting the visibility of drawings you want to trace through, and many engineers' drawings are the product of layering one image on top of another. One rudimentary grid can act as an underlay for drawing an infinite amount of things at any scale in quick sketches. And these are examples of 3 drawings of different things constructed over the grid, sharing the same horizon and vanishing points. This is a section through a house, treating the house as a see-through structure. This is an exploded view of 4 floor plates. And this is a cutaway detail of a space with a set of steps. In this exercise, we will apply what we have learned to make a drawing of a 9-meter high structure from the viewpoint of a person at street level. In architectural sketches, figures are represented as 1.6 or 1.7 meters tall. So in this grid, the horizon is 1.7 from the base of our shape and literally goes through the eye level of a figure. Start your drawing by projecting all heights on the vertical measuring line back to vanishing point 2. And then estimate a 6-meter distance from the base of your vertical measuring line where your person is stood. Estimating distances gets easier the more experience you have, but in the early stages you might deliberately make the distances too long or too short until you get something that feels about right. Draw a vertical line at this point. Then, at the 6-meter height, draw a diagonal down to the bottom right-hand corner of your grid. Make dots at the point where horizontal lines 0 to 6 intersect with your diagonal. Finally, using a straight edge, draw vertical lines through each of the dots to complete your 9 by 6 meter perspective grid. This gives you a grid that you can measure 1 meter distances with. And we can now start to draw shapes on the grid, and we will draw a 3-story structure starting with the front elevation, which we draw directly onto our grid. Now we can make the front elevation into a 3D structure by projecting corners of horizontal lines 0, 3, 6 and 9 to VP1. Then we estimate again, this time a 3 meter horizontal distance from the leading edge of your shape in the direction of VP1. Draw a vertical line from the bottom of your shape at this point to give you a 3 meter depth. Complete the shapes of all the 3 boxes in 3D, first in blue pencil, then with ink pen. You can see the volumes in 3D, and we're looking now at the way figures can be placed to show the scale of your structure. Figures in 2-point perspectives recede to the vanishing points, but do not diminish as they go up high or down low. All figures that are plotted exactly the same distance away from the vanishing points will appear to have the same heights. This applies equally to all structures constructed on your grid. This is just one grid, but it's the source of an infinite number of sketches. As you learn the basics of constructing forms in space, you should experiment with allowing the grid to suggest forms to you as an improvisatory exercise. Here I am applying the method of duplicating the width of one plane from the basic grid by the diagonal method. And here, another variation shows a cutaway of the structure behind a facade of a 3-story building. This is an example of a good use of perspective drawing, as it gives us an impression of looking down on a space that has had a wall cut away to show details. The engineer has itemized the components in the small isometric sketches surrounding the main drawing. The whole sheet is evocative of the construction process and represents the engineer thinking through and communicating assembly details.